if you open up the script called motor experiment, this will be the script that will run a real motor, and at the same time it will run a virtual motor. What I like to do first is look at the motor controller. So let's go into the motor controller, and in here we are looking at the variable motor speed. In this forever loop, it only starts when we have seen that the message start motor has been sent, which is broadcast by the stage script. So what this control script does is it first checks if motor speed is lower than 1, it'll set motor speed to 1. If motor speed is greater than 150, it'll set it to 150, and then here it sets motor 11 to motor speed, and then finally it sets motor 11 display to 1 over motor speed. Now I'll explain these two. As with the flashing LEDs, we have some preset variables that directly control the GPIO output pins. One of these we will use here, and it's called motor 11. So whenever motor 11 is set to a number between 1 and 150, the output pin will switch on and off. The frequency of the on and off cycles is set by the value we give to motor 11. Let's say we set motor 11 to 150. That will cause the GPIO pin to switch on and off very fast, so effectively our motor remains switched on, so we get full speed. Now if we set it to say 1, so that means our motor can never get up to any decent speed. Effectively it means we set the speed of the motor to a very slow speed. So this is how we control the speed of electric motors, via on and off switching. Now the other variable, motor 11 display, this one here, needs to be used so we can activate the turning of our virtual motor on the computer scratch stage display here. This acts as a virtual motor. Now here we just take the inverse value of motor speed, so that we have small time delays for large values of motor speed and large time delays for small values of motor speed. So to summarize, this is all this control script does. First of all, it sets the variable motor 11 to the GPIO output pins cycling on and off switching speed of motor speed here. And 2, it sets motor 11 display for the virtual visual representation of our motor on the stage here. So if we now look at the actor virtual display, so we'll open that up. This is the only actor which represents the propeller. That's the costume for the actor, the propeller. So if we look at that, we see all he needs to do is, after the motor has started, use motor 11 display's value, in other words the value that was set by the control, to set a time delay in seconds. First of all, like the others, he waits for the start motor broadcast message, then he enters the forever loop, he turns a certain amount of angle, and then he waits moment 11 display seconds. So if that's 4, he'll wait 4 seconds. If that's 150th of a second, he'll wait that amount of time. That then gives us the stage display of the virtual motor, e.g. the propeller, moving fast when the real motor runs fast and slow when the real motor is also running slow. Now let's look at the stage script. Now the stage script does not need to know any details about how the real motor works or how our virtual display works. Doesn't need to know those things. So he sets motor speed to a low number for slow speeds, and he sets it to a high number for fast speeds. That's all he has to do. When you're actually writing this script, you don't have to think about what's going on in the virtual display script and the control script. You can just purely concentrate on setting motor speed to a value between 1 and 150. This means our stage script is very simple to code. The set of instructions here, for example, is just one example of how to control the motor speed. So there's many other ways you could do this. I've just randomly picked this way. Basically what I'm doing here is I'm repeating increasing the speed until we very close to the maximum speed, and then we stop increasing, and then this one decreases it. So when we've hit that maximum value, it'll go through this loop and it'll start decreasing it, and again when it hits a value that is smaller than 15, I've just an arbitrary value here, it will stop changing basically, because that's the minimum value. But until it reaches 15, it will decrease by -15. So that's how this particular loop works. But you can write any type of loop you want here using motor speed. Whatever you set motor speed to will change the speed of the real motor and the virtual motor. Looking again at the control script, let's do that. Let's say, for example, we set motor speed to 10. Then that means 1/10 of a second will be our pause time for the virtual motor display. So you can see 1/10, 1/10 of a second. That will mean that when we're in here, this guy will wait for 1/10 of a second. We say set the motor speed variable to 1 though, we'll have 1/1, which is 1 second. Obviously that's going to mean that this virtual rotor is going to be very slow. Remember, this motor 11 display is just purely to do with the virtual display. It doesn't affect the motor at all. The only one that affects the motor is this motor 11. So we have to do both of them obviously, and we do them at the same time so that they kind of slow down at the same time and they speed up at the same time. For example, if we were to choose 150 for motor speed, then that's a very, very short time delay, which shows our propeller, then this propeller will be moving at the maximum speed that we've defined to be 150. Choosing anything over 150 I found just doesn't make any further difference really. That's the maximum, and 1, it'll only go down to 4, so even 1's too slow for it. If we go back to the stage and just have a look at that, what I did here was I added some keyboard controls, and that was using these sense controls here. So when the up arrow is pressed, we set the motor speed to 150. When the down arrow is pressed, we set the motor speed to 4. And I just picked two arbitrary numbers here for the left and right arrows. So when it's left, I just set it to 10, and when it's right, I set it to 20. Anyway, let's run the motor and I'll just show you that the automatic script here and what happens when we hit the up and down arrows. So let's take that back over. So we'll quickly run it, and there it goes. You can see it's moving. Now I'm just going to override the actual main stage script by hitting the up arrow. Now I hit it now, and look, it's automatically puts it to the maximum speed. I'll hit the down arrow, and that puts it to 4. If I hit the left arrow, then I'm going to get 10, and you can see that's 10. If I hit the right arrow, I get 20. Now I can just I'm holding my finger on the right arrow, and that's going to keep it at 20. If I hold my finger on the up arrow, that's going to keep it at 150. Hold it down on the down arrow, and it keeps it at 4. So that's what those 4 controls will do. They'll actually override the main stage script, all the while we're holding the key down. By using this variable motor speed, we are effectively setting both the virtual motor and the real motor speed. So motor speed acts as a proxy, if you like, for the virtual motor and the real motor. I'm going to switch this on again, and what I want you to notice this time is the notify string here. I've placed in a notify, a variable called notify. Now if you put text in a variable, it will appear as text. So that's quite nice. So what we can do is we can put words and phrases in here to tell us what's going on while we're going through the script. So here I've put section 1. It tells us where we're in section 1. Here I've put section 2. Remember, this is all in a forever loop. So I've put notify section 2 in here and notify section 3 in here. So wherever we are in here, we'll know by looking at this variable. And also I'm showing the motor speed. So if we just run this again now, we can look at what happens and where we are in the code as it's running. So let's just run that again now. So first of all, we're in section 1 and we're moving at about 4 speed, then 34, 49, 64, 79. We're in section 2, 124, 139, 150, and it's staying at 150 for about 4 seconds in that delay. And then look, we're in section 3 now and it's going down, 120, 90, 75, 60, 30, 15, 1. So now we're back in section 1 again, and it just repeats that cycle. So that shows it's useful to actually show some of your variables. You can tell exactly what's going on and where you are in the code. That's the whole script really. Before we do the actual last video, we're going to do the tutorial video next, because I just want to give you some ideas about how to adapt this program I've just shown you here now. You're going to modify it. You can call your modification Motor Experiment 2 or whatever you want to call it, and then when you come to the class, the script that I'm going to ask you to write or modify it in your own way, it doesn't really matter if you follow the exact instructions I give you, then we can run that on the actual motor that will be in the classroom, because I'll have a real motor in the classroom. So that'd be fun. You can come up with some movements of the motor, you know, speed it up, slow it down, stop it, start it, do whatever you want, and then we can actually run it on the real motor. And of course when you're at home you can watch the virtual one and you can test it out, make sure it works as you want it, and then it'll work. It should work on the real motor exactly the same way.